Hello, this is Andy from Engineers Academy, and in this video tutorial we're going to be producing a simplified electrical backbox using Autodesk Fusion 360. Now the component that we're going to be drawing is an actual electrical backbox, but we're going to simplify some of the features, and the reason we're going to do that is so that we can practice using Fusion to create some relatively basic geometries and features. If you're accessing this video through the Engineers Academy study platform, then you'll also have access to an orthographic drawing of this component. However, if you don't have access to the study platform, then you can follow along and follow the steps in this video in order to produce the electrical backbox for yourself. So we're going to begin with the general outside geometry of the backbox. Now I'm going to be referencing the drawing as I go through this video, as I have the drawing in front of me here. So we're going to start with a sketch, and we're going to select a plane to sketch on. Now, with reference to the drawing, I know that the overall length of the backbox is 147 millimeters and the overall height is 50 millimeters. We'll look at the depth of the backbox in a moment. So, taking a rectangle then, I need to create a rectangle of length 147 millimeters. I type the dimension for the length in the box, and when I press Tab, I can input the dimension for the height, so 50 millimeters. Once I've created the outline for the front face of my backbox, I can click Finish Sketch. Now the next step then is to extrude the thickness for the outside of our backbox. I'm going to use the extrude function, and I'm going to drag the arrow in the direction that I wish to extrude. Now with reference to the drawing, I know that the overall depth of the backbox in this particular view is 86 millimeters. So once again, I'm going to input 86 and hit enter. So what we have so far is relatively basic, but it's the outside or the starting point for our electrical backbox. The next feature I'm going to do is add a thickness to the walls of this backbox, and there's a number of different ways that you can do this. One way might be to use the shell tool that we saw in the previous video, but I'm going to use an extrude cut function just so that I can demonstrate some other features as we go along. So I'm going to sketch, and I'm going to sketch on the top face of the cuboid. And when we do this, you'll notice that the geometry reorientates. Now I'm going to draw a rectangle, and I'm not going to define any dimensions, so I can draw this anywhere in space. Because the important dimensions for me here are that we need to specify a thickness on each face of 3 millimeters. We're essentially going to create a 3 millimeter shell, but we're going to do this using extrude cut functions rather than the shell function. So I'm going to dimension my first face, so between the side of the rectangle and the side of the electrical box. This distance here is 3 millimeters. I'm going to select the next face and the outside of the box, once again 3 millimeters, and I'm going to repeat that for the remaining two sides. Now it doesn't matter if your dimensions overlap the model that we're creating, as they're going to disappear once we extrude this object. So finally, I'm going to pan the object, I'm going to hit Escape to return to the previous tool, and I'm going to specify my final dimension. Okay, now I'm going to finish the sketch because we've got a fully constrained rectangle there, and I'm going to orbit the shape so that we can see visually the sketched surface. Now the next function I'm going to perform is an extrude cut. If you recall, the height of this backbox was 50 millimeters, and we want to create a 3 millimeter wall thickness. Therefore, I'm going to need to extrude cut down by 47 mil. So I select my extrude tool, I switch from new body to cut, I specify the downwards direction, noting that we have a negative direction here, and I'm going to input -47 as my measurement. So now we have the basis of our backbox. Now the other thing that I'm going to do here is add fillets to the 4 edges. These edges here, 1, 2, 3 and 4 currently out of view. These are the only 4 edges that we're going to fillet, but it means we get some practice using the fillet tool. So I'm going to select the fillet tool, we have 4 edges, as I mentioned. 1, 2. Just rotate the box. Press Escape to return to the fillet tool. 3, 4. And my fillet radius here is going to be 3 millimeters. Once again, this is labelled on the drawing for these 4 edges. So it's 3 millimeters. And then I can click OK. So now we have our neat corners or our filleted edges, removing the sharp edges there or the sharp corners. Okay, now we have a number of other features that we're going to add to this box. And the next part that we're going to add are the pillars where the utility screws would go. Now, utility screws are used to secure the front of the electrical socket to the back box, but we're going to create some pillars here with holes so that we could allow for those screws to be placed into the back box from the front of the socket. So once again, I'm going to create a sketch. This time I'm going to sketch on the inside face of our back box here. Now, the next thing that I'm going to do is create a dummy center line. So I'm going to add a line, but it's not going to feature in our final sketch. So on this edge here, I want to snap to the center of the edge. Now, we have various different snap functions. When we see a triangle appear like so, we know that that's going to snap to the center of that edge. You've got various other constraints and snaps here that you can use if you wish, but we're using the center line snap here, and I'm just going to draw a vertical line straight through the object. So we know that that sits at the center of the shape. I'm then going to draw 2 circles, and both of these circles are going to have a center point on this line. Now, once again, we're not too concerned with the size of these circles at the moment, as we can dimension them afterwards. So they both have a center line here. Now, as I refer to my drawing, I can see that the overall outside diameter for each of these circles is going to need to be 12 millimeters. So using my dimension tool, I'm going to select the circle, 12 millimeters, then do the same for the other circle, 12 millimeters. The other thing we can see from the drawing is the distance from the outside edge here to the center of that circle is going to be 13 millimeters. So again, I'm going to take my dimension tool. I'm going to dimension from the edge. Note that this is the outside edge to the center of the circle. And I'm specifying that as 13 millimeters. I'm going to repeat for the other side. We have the outside edge to the center of the circle, 13 millimeters. Now, the last thing that we need to do is connect the tangent of this circle, and we need to connect it at a right angle to this line here. Now, there's various different ways of doing this again, but I thought it'd be useful to use some of our constraint tools. Let's pan in on the first circle so that we can see what we're doing here. So we're going to start with a line that's on the tangent of the circle, and we can ensure this in a moment, and it finishes on the outside here. And we can do the same on the other side. Now, what you'll notice at the moment is although we have a right angle here, so we know the line is perpendicular to our baseline here, we don't have a tangential constraint here. As we don't have a tangential constraint here, we can see that that line doesn't touch the outside of the circle. Let's once again move in a little bit closer so you can see this clearly. When we apply the tangential constraint, so we select the constraint, we select the line, and we select the circle, we can see that in order for both of those conditions to be true, so a right angle here and a tangential line here, the line has been moved to the outside edge of the circle. We'll see that again here. We select the line and we select the circle. Now, all of our conditions have been met for that pillar or the sketch of that pillar. Let's repeat on the other side. So we know that we want the lines to be tangential to the circle, and we also know that we want them to be at right angles to the baseline. We can click anywhere on the circle because our constraint will fix that afterwards. But we want it to be at right angles like so. And again, anywhere on the circle and at right angles like so. Then using our tangential constraint, we click the line, we click the circle, and it fixes that constraint for us, like so. Now I'm also going to add a line from each of the corners of the lines that we've just produced, and that's so that we have a complete sketch. And you'll see why we need that in a moment. I need to do the same at the other end. Again, so that we have a complete sketch or a closed profile, if you like so. Finish. The next function we're going to perform then is an extrude. Now, when we refer to the drawings, these pillars do not go all the way to the top edge. In fact, the finished height from the outside face of the back box is 43 millimeters. Now, don't forget that the thickness of this back box is already 3 millimeters, so we only need to add a further 40 millimeters. The end result is we're going to have a 7 millimeter recess between the top edge, or the front face here, and the front face of the pillar. Again, if you refer to the drawing, you'll see this more clearly. But I'm going to do each of these extrudes together. Need to make sure I select all of the profiles that I wish to extrude. 4 faces there. Going to do the same on the other end. 1, 2, 3, 4. And I'm going to extrude. This time I'm joining material. So rather than new body, I'm going to specify join, because this is going to join to our existing box. And for the reasons mentioned previously, this needs to be 40 mil. What we end up with then is a 7 millimeter return here between the front face of the box and the top face of the pillar. Now, the other thing that we've not yet done is we haven't shelled the inside of each of these pillars. Now, again, we could use the shell function in order to achieve this, but I'm going to do this using extrude cut because I want to show you how you can apply an offset to an extrude cut. So we need to sketch on face again. So if we use the offset tool and we select our first curve, we can now specify an offset of 3 millimeters. Note that we have a minus here. We need to take care with that. So we have minus 3. So let's continue. And what you'll notice at the moment, we've offset each edge of that particular feature. So I'm going to add a few extra lines on here. Going to add a line 3 millimeters in this direction, so that meets the wall. I'm going to add a line 3 millimeters from the other side, so that it meets the wall. And then I'm going to close off the profile. Okay, let's finish the sketch. So we have everything we need here in order to perform our extrude function. I'm going to pick the 2 faces that I wish to extrude, and I'm going to orbit this slightly so we can see what's happening. Now, we want to cut material out for this pillar, but what we don't want to do is cut from the top surface. We want to offset the cut by 3 millimeters. So essentially we're going to have a 3 millimeter shell throughout the inside of this particular component, or this pillar here. Now, the way that we do this is we select our cut function, we specify our direction. Now, the direction here is unimportant so long as it goes the whole way through the box. So we'll set that to 53 millimeters, knowing that the box is 50 millimeters deep. But where we have this start position here, we're going to specify that we're going to start at an offset. Now, the offset is going to be 3 millimeters. But just take care here, because when we've inputted 3, we notice that it's 3 millimeters above the face whereas we want it 3 millimeters below the face. Again, this is because of our positive and negative directions. So let's specify -3. It drops below the surface. We can see that in the preview, and it's going to cut all the way through the part. That's exactly what we want. Let's click OK. It doesn't look as though anything's changed, but if we look at the underside of our part, we can see that it's shelled that pillar, but we've still got the thickness of the material on the top face. Let's just repeat everything we did there for the other pillar. So we're going to sketch on the top face there. Zoom in. First thing we did was offset the outside edge. We offsetted 3 millimeters to create our thickness, noting that we need to type -3 because it's the negative direction. We then extended each of these lines to the edge of our box. There is an extend function, but for simplicity, I'm going to use the line tool. And we need to remember to close off that profile. We can then finish the sketch. We can extrude, select our two faces, orbit so we can see what's happening, pan and hit escape. We're performing a cut. We're performing a cut in the negative direction to at least 50 mil, but we're applying an offset, and the offset is -3 millimeters because it's 3 millimeters downwards. Okay. Now we can see that what we have is everything we required. We have a 3 millimeter shell on the top face, and the rest of the material has been removed underneath. Now to complete these pillars, we're going to cut a hole of 5 millimeters in this pillar and a hole of 5 millimeters in this pillar, and we're going to align that with the center of the previous circles. And as mentioned previously, this would be to allow for the fixing for our utility bolt. Let's sketch on face. This is a relatively quick operation. We need a circle which shares the center we had previously. Diameter 5 mil. Finish sketch. Extrude cut. Cut. It only needs to go down 3 mil, but we can go further. Okay. Same for the other pillar. Top surface. Circle 5 mil. Finish sketch. Extrude cut. Again, so long as the depth is over 3 millimeters, that will remove the material for us. Okay, let's have a look, and we're going to use our viewing planes in the top right corner. We're going to have a look at the top face. So we can see that each of those holes are cut right the way through the pillars. If we orbit that round, then from the underside, we can see that we still have the shell thickness on the top face, but we can see that we have a cutout that goes through the face that's 3 mil thick. Now we've completed those two features. We have 4 features remaining, and they're identical, and they're for the screw holes in each of the 4 corners of the back surface of the box. So let's sketch on face. Just make sure it's selecting the inside face, like so. Now, once again, we could draw one of these at a time. We can use something called a pattern, and we could apply that pattern to the sketch or to the extruded geometry. But I'm going to produce these using the standard sketch tools to give us an opportunity to have more practice with those. So I'm going to draw 4 circles. And these circles can be anywhere in space for now. Each of these circles is going to have a diameter of 5 millimeters. So let's use our dimension tool, dimension each of those. And then we need to position the centres of each of these holes. The centres of each of these holes are 13 millimeters from the outside edges of the box. Now again, I appreciate there's quite a lot of repetition here, but what I want to do is give you an opportunity to practice using these tools. 13, 13. We do each circle in turn. Again, the dimensions can overlap the model. And the last one, outside edge to centre, outside edge to centre, like so. Now we're going to perform an extrude cut, and we're going to cut down into the bottom face of the box. However, we're only going to extrude through half the thickness. You know that the overall thickness is 3 millimeters, so we're going to extrude through a depth of 1.5 millimeters. Let's finish our sketch, extrude, and pick our 4 circles. Now once we've picked our circles, we can orbit so we can see what's happening here. Okay, this all looks fine. We're performing a cut. We're cutting downwards, and we're cutting downwards by 1.5 millimeters. So minus 1.5 is the dimension. Okay. The next thing we're going to do is apply a chamfer to each of those circles. Essentially, we want to create a 45-degree angle that would support a countersink screw. So the top edge of each of those circles is going to be chamfered at 1.5 mil. We have a chamfer tool, modify, chamfer. We're going to pick the edges as mentioned. So the edges are top edge here, top edge here, top edge here, just make sure that it's the edges that you're selecting rather than the face, and the edge here. We can check because in our sidebar here it tells us we have 4 edges, and we're going to specify 1.5 millimeters. We've also specified the type is equal distance. Now if we look at the preview of each of those features, we can see that it's done what we wanted. We have 5 millimeters at the bottom of the cutout, and we have 1.5 by 1.5 or a 45-degree chamfer. Let's click OK. Now the final part then is to continue the circular cutout on the bottom face, the 5 mil cutout, and we're going to go through, but not all the way through the material. We're going to go through another 1.25 mil. Essentially, we're going to leave 1/4 mil skin on the underside. Now, if you've seen these back boxes, they'll have a breakout section so that you can break the holes out just for the places where you want to input the screws. Now, let's do each of these again. So we're going to select them all at once. Going to select extrude cut and select the 4 bottom faces of each of those circles or each of those cutouts. So we have 1, 2, again orbiting the object, 3, and the final one, 4. We're going to extrude cut, and our depth, as previously mentioned, is minus 1.25 millimeters. So not quite through the full face of the part. Okay, so now when we orbit that part, we can see that we have an additional cutout that doesn't quite break through the back of our component. Okay, so now that we've created our component and we've created our features for the pillars and for the screw holes, the last thing that we need to do is assign the material to this particular component. Once we've assigned the material, we can check the volume and the overall mass of the electrical back box. So if we expand the bodies menu, there's only one body. The first thing we're going to do is right-click Physical Material. And the material that we're going to assign to this component is UPVC. Now UPVC is unplasticized PVC, and essentially it's a hard, rigid version of polyvinyl chloride. So in this list here, we're looking for UPVC. So here we have PVC unplasticized, or UPVC, and we can assign that material to our component. So to finish then, we can right-click on our body and we can select Properties. We can see here that the volume of our component is 1093 times 10 to the 5, where 10 to the 5 means we move our decimal place 5 places to the right. So we have 109,300 millimeters cubed. Once again, we can see that our material is specified as UPVC, and we can also see the mass of our component as 141.033 grams. So we have the material assigned, we have the volume, and we have the mass of that electrical back box. So I hope you found this video useful, and thanks for listening.